Okay. An aircraft is flying at a height of 3,400 meters above the ground. If the angle subtended at a ground observation point by the aircraft positions 10 seconds apart is 30 degrees, what is the speed of the aircraft? So I think what they're trying to say here is, let's say this aircraft. So you are seeing it from here. Let's say you are standing here. So this height is 3,400 meters above the ground. If the angle subtended at a ground observation point by the aircraft positions 10 seconds apart is 30 degrees. So suppose if I say that somewhere here, so the aircraft has come over here, so it means this is 30 degrees, and it took 10 seconds for it to go from here to here. What is the speed of the aircraft? So using this, I'm supposed to find the speed of the aircraft. But they didn't say that it is vertical, right? So it can be anywhere. So, but let's try this. So this is the height is given here. This distance I do not know. So let's call it as x. So I can say tan 30 is equal to opposite by adjacent. So opposite is x, adjacent is 3,400. So tan 30 is 1 by root 3. So x is equal to 3,400 divided by root 3. But then they're asking you to find the what is the speed of the aircraft, which means velocity is equal to distance by time. So the aircraft has gone this much distance in 10 seconds, which means distance by time is equal to 3,400 divided by root 3 divided 10 seconds. So I'll cancel this and this.
So,
Yeah.
so the answer is 119.33.
119. Is that correct? Anybody else? I have written it as 196.3. 119 or 196? Double check it.
So 1 second, sir.
So can cancel this 0 and this 0. I can take this as 1.7. So if I cancel this and this, it will be 20. So very close to 200 is what I will get.
So it's 196.29.
Yeah. 196.29. Okay, I have taken the approximate numbers here, very close to 200. Any questions here? Quickly take a look at it. But as I said, the question is not very clear, It could have been something like this also, because they didn't say the observer is vertical this way. If angle subtended at a ground observation point by the aircraft positions 10 seconds apart is 30 degrees. So that means what I'm trying to say here is it could have been like this. The aircraft is here. And then I'm observing the aircraft, and then the aircraft was here. And this could be 30 degrees. In that case, I would have taken this as the distance x. But then this height is still known, 3,400 meters. In that case, I would say some of the information is missing here. H, small, but I couldn't have found this. Okay, for now, take it down. I will double check it. I don't know if they're saying like this or if they're saying like this. I could still, take it like this also. Okay, so I'm just saying that this is also possible from what is given. But for this, I don't know if we have enough information. Okay, so for now, take it down. Let me double check, if they mean this one or this one. Copy it. Can I change the screen?
Yes, sir.
There are some interesting projectile motion problems here. So let's try a couple of them. These things you need some vector knowledge from your mathematics. So for now, I will skip this. Okay, so we can do this 29, 30, 31, 32. These things are easy. So we can do these things first. Bullet fired at an angle 30 degree with the horizontal hits the ground 3 kilometer away. So that means adjusting its angle of projection, can one hope to hit a target 5 kilometer away? So it means a bullet is fired like this, and let's say it's going all the way, something like this. So this is a 30 degree, and this is a 3 kilometer away, 3000 meters. By adjusting its angle of projection, can one hope to hit a target 5 kilometer away? So you know that the maximum range can be attained only at 45 degrees. So that means I can calculate for 45 degree and see whether I'm getting, more than 5,000 or less than 5,000. If it comes less than 5,000, then there is no way you can hit a target 5 kilometers away. If the 45 degrees gives me more than 5,000, then I will say that it is able to go farther than 5,000, which means it will be able to hit the 5,000. Assume the muzzle speed to be fixed and neglect air resistance. So range, you know that range is equal to u squared sine 2 theta by g. Okay. So sometimes it's very handy to remember these final formulas. Okay. If you don't remember, then you have to start from the basics, quickly derive this. So range is 3000 here. U, I do not know, u squared sine 2 theta. Sine 2 theta means sine 60. Sine 60 will be root 3 by 2 by g is 10. So using this, I'll be able to calculate the u. So once I calculate the u, you can substitute for the range max. So R max is equal to u squared by g, and then sine 2 into 45. 2 into 45 will be sine 90, which means it will become 1, because theta is equal to 45 degree for maximum range. So you don't even have to calculate the u. Calculate the u squared here and then divide by g. So u squared by g, this is u squared by g. So that means u squared by g is nothing but, according to this, u squared by g is nothing but 3000 by sine 60. 3000 by sine 60 is root 3 by 2. This will become 6000 by root 3. So 6000 by root 3 is 1.7. How much is that? Approximately 2. So it will become 3000, 1.7. The answers 1.7, 17, 60, 15, 4 times 4.
So be 3.5 3.52 into 10 to the power 4, sir. 3.52
3.52 into 10 power 4, which is 3520 meters, which means
So
that
it's actually 3529 meters. You can say approx 3529.
okay, anyway, it's very far away from 5,000, right? So that means you can say that it's never going to reach 5,000 kilometers. Sorry, 5,000 meters. You don't following what I'm saying? So they asked you to find whether it will be able to hit a 5,000 meters target or 5 kilometer target. And my max range itself is coming only 3529. So that means you have to say that 5 kilometer target cannot be hit. That's all. Any questions? Any confusion? Can I change the screen? Will be copying. Okay. Fighter plane, I think this is also a very interesting question. Let's try that. A fighter plane flying horizontally at an altitude of 1.5 kilometer with speed 720 kilometer per hour passes directly overhead an anti-aircraft gun. At what angle from the vertical should the gun be fired for the shell with muzzle speed 600 meter per second to hit the plane? So as I told you in the theory, very often you will get these kind of, hitting the target kind of questions, military engineering problems. So the plane is like this, flying horizontally at an altitude of 1.5 kilometers. So that means this is 1.5 kilometers. And there is a anti-aircraft gun, like shooting the gun, shooting the aircraft down.
So right side towards the airplane.
Right side?
So from the point, the circle, it will go right side.
Yeah. So that means if the plane is going here, right? If I shoot it here, you may be thinking, sir, why can't I shoot it here? Well, by the time the bullet goes here or the missile or something goes here, the plane would have gone somewhere here, which means you have to make the calculation such that you have to fire the missile in this way so that, by the time the plane comes over here, you will be able to hit the target. Okay, something like this. So you have to match this and this. This will not work. So that's the question. So that means they are saying that the muzzle speed is 600 meter per second. And then this is going at 1.5 kilometers, speed of 720 kilometer per hour. So the aircraft is going at 720 kilometer per hour, which makes sense, right? Usually our passenger aircrafts will be going at lower than 1000 kilometer per hour. But this one, they could have given a little bit higher value because this is more like a military aircraft or supersonic aircrafts, right? At what angle from the vertical should the gun? So that means they're asking you to find this angle, theta, to hit the plane. At what minimum altitude should the pilot fly the plane to avoid being hit? So it means on the first problem, we are calculating, which angle I have to fire this so that, this guy will come here and then this will hit the target.
Sir, if we have to find the distance, like at what point will they make? This is nearly a, what do we say, a right angle triangle, do we say, or do we not say right angle triangle?
Now think about it. the projectile motion is going to go something like this. So that means
Fine,
it's
sir.
definitely not going to be a right angle triangle, right? It's going to be
Fine.
like a curved path. So you cannot use right angle triangle here. Any ideas how to do this?
So theta is equal to opposite by adjacent. It won't work, I guess.
Well, that's what I was answering now. So
Yes.
you guys are thinking that it is,
So
triangle.
first
but
we'll
it's not.
use sine theta.
U is
Find the
given, so I
fraction.
can say u cos theta can be found, but I don't know the theta, but I'm going to keep it as ux is equal to u cos theta, and then uy is equal to u sin theta. But one clue I'm getting here is by the time the plane comes here from here to here, right? When this covers this distance, this missile should also cover the same x distance. Do you agree? Even though it's going in a projectile motion, do you agree that this, by the time the plane covers say 10 kilometers here, this missile should also cover 10 kilometers in the x direction? Do you agree or not?
Yes, sir.
Yes, sir.
Because this and this are, they said, vertically above head, overhead. So it means this and this are in the same line. So that means this distance and this distance are same. That's a clue. If you know that, you can easily do this problem. So it means the time taken for it to come from here to here will be same as the time taken for the missile to go from here to here in the x direction. Of course, it's moving in the y direction also, but then in the x direction, it should have sufficient velocity to cover this distance. So that means here I'm going to say that Sx is equal to ux into time of flight plus half at square. But you know that ax becomes 0. So that means it's going to be only ux into t. So, but I don't know the time. So, but I know the time taken for this and this are same. Okay, if it takes 10 seconds for the aircraft to come here, missile should also take 10 seconds. So that means this one I'm going to say that this distance d is equal to speed into time. It will look very similar to this. If you forget about this ax, distance is equal to speed into time. So speed is 720 kilometers per hour. Kilometers is into 10 power 3 meters divided by hours is 3600. Converting into meter per second. Because here I have in meter per second. So time taken here is also t. Here also it's t. Distance is going to be same for this and this. So that means I'm going to call this as equation 1. I'm going to call this as equation 2. So distance has to be same and the time taken is also same. So what I'm thinking here is if I equate this and this, time is same, so t and t will cancel. So ux will become equal to this one. So ux is nothing but u cos theta. So let me go step by step. So I'm saying the distance covered is also same and the time taken is also same. So 720 into 10 power 3 divided by r, I could have cancelled this.
So it's 200, sir. 200 meter per second.
Yeah, so it's 200 meter per second. So 200 into t is equal to ux into t. Ux is nothing but u cos theta. U is 600. So that means I can say 600 cos theta into t. So t cancels. So this will become 1 by 3. Cos theta is equal to 1 by 3. So whatever that is the answer. So theta is going to be cos inverse of 1 by 3. Okay, so either you can use your calculator or your tables and find out the angle. Anybody not following? So I'm simply saying that the distance covered here and the time taken should be equal to the distance covered here and the time taken, because missile also goes the same x distance and the time taken should be same. So that means you have to fire it at an angle of 1/3, cos inverse of 1/3. So with vertical, I think you will get an answer something like 19.5. Anybody in the calculator?
Yes, sir.
So take it down as theta is equal to, I don't have space there, so let me write here, approximately 19.5 degrees with vertical. Okay. So they said with vertical, so that means you have to calculate this. Anybody having any doubts? Anybody? It's all about, converting this English to drawing. So if you do that, that's the first step. Okay, what is the second part? At what minimum altitude should the pilot fly? So now we calculated this. So if you hit it at this angle, this missile will hit the plane. But now they're asking, okay, what does this pilot should do? He has to fly a little bit higher so that, this guy does not hit him. So that means so the anti-aircraft missile is something like this. So let's say it's kind of going something like this and then going to take a path like this. So if the plane was flying at this level, so definitely he will reach this H max point. Okay, based on that, this and this will match. But we don't want that to happen. So this guy has to fly higher than this. Only then, he can miss this. So that means basically I have to find the H max. So if I calculate the H max here, they already said that he's flying at a height of 1.5 kilometers. So calculate the H max in this situation. And then that will tell me, if this pilot is flying above this H max, then he's safe, because the missile will go like this and then take a projectile path. It's not going to go further up. So that means H max formula, H max is equal to, anybody remember, u squared sine squared theta by 2g, I think. Okay. V squared is equal to u squared plus 2as. So this becomes 0. U is uy sine theta. So u sine theta the whole square. 2g will come in the bottom. So this is your H max. So if you don't remember this, you have to start from here. A is G, S is your H max. U is 600 square. Sine is sine. So since we calculated theta as 19.5, right? Using that, you can calculate this. So sine squared 19.5 divided by 2g into 10. Sometimes you may not be having a table. So what you can do is that cos theta, we found it as 1/3. So that means, can anyone tell me what will be sine theta?
Root 1 minus 1/9.
Very good. So
1
you
by
should
9.
remember this formula, that sine squared theta plus cos squared theta is equal to 1, which means if I want sine theta, 1 minus cos squared and then square root. So 1/3. So it will be 9 minus 1. So it will be 8/9. So 8/9 square root. And since there is a square here, the square root will go away. So that means it will be 600 square into 8/9 divided by 2 into 10. So do the math and we'll get the answer. So this is an important trick in trigonometry. Okay. So whenever cos theta is known, you can calculate the sin theta. Or whenever one of them is known, you can calculate sin theta, tan theta, all the other things. Okay, so make sure you understand this or remember this. So if you do the math, I think you will be getting something close to 16 kilometers. So you see he's flying very, very low here at 1.5 kilometers. Only if he goes up to a height of 16 kilometers, he can, miss all this missile guy. Otherwise, there is a possibility that this missile will hit the plane. Any questions, any doubts? So basically, we are applying the projectile motion concepts into real life problems. Okay. Cyclist is riding with the speed of 27 km per hour as he approaches a circular turn on the road. Okay. So I think it's something to do with circular motion. Let's try that. A cyclist is riding with the speed of 27 km per hour. As he approaches a circular turn on the road of a radius 80 meters, he applies brakes and reduces his speed at the constant rate of 0.5 meter per second every second. What is the magnitude and direction of the net acceleration of the cyclist on the circular turn? So the cyclist is going like this. So what they're saying is he's approaching a circular part of the road. So here he is going at 27 kilometers per hour. As he approaches the circular turn on the road of radius 80 meters. So radius is 80 meters. He applies brakes and reduces his speed at the constant rate of 0.5 meter per second every second. So what does this mean? Anybody? What is the meaning of this?
Deceleration.
Deceleration, very good. So that means constant rate of speed is reducing. So every second the speed is reducing 0.5. So in the first second, suppose if it was say 5 meter per second, after 1 second it will be 4.5. After one more second it will be 4. After one more second it will be 3.5. So it keeps on decreasing for every second. So at the very first class or somewhere I told you this, acceleration is nothing but meter per second per second. Okay. And this is what we write it in a very confusing way, which is meter per second square. So meter per second square does not make any sense. What makes sense is meter per second per second. So every second the speed is decreasing. Okay. Since in this case it is decreasing, you have to put a minus. That means the acceleration is equal to this much. That's what is given in a straightforward way, but you are used to this confused way. Okay, so both you should be knowing both the things. What is the magnitude and direction of the net acceleration? What do they mean by net acceleration? Any idea? No idea. What do you mean by net acceleration? Is there only one type of acceleration or two types of acceleration in this problem?
So two, so one acceleration, one deceleration.
Okay. What acceleration is this?
Deceleration.
No. I'm asking, is this centripetal acceleration or tangential acceleration? This one. Centripetal acceleration, does it change the speed or just change the direction?
changes the direction.
changes the direction. So
Changes only the direction. It doesn't change the speed, which means what does this mean? What acceleration is this? Tangent shift. Okay. So you see, this theory is not given in the textbook, but then there is a problem. That's why I say, sometimes you have to know more than what is given in the theory. So this is AT. So make a proper note. This is tangent shift. Doesn't matter whether it's plus or minus. Okay. All you can say is tangential acceleration. Since he's going in a circular turn, right, there must be a centripetal acceleration. So centripetal acceleration, I'm going to call it as AC. If you want, you can call it as radial also, centripetal or radial. Anybody remember the formula? AC is equal to formula. Nobody remembers centripetal force formula.
So AC is equal to V square by R.
What did you say? I can't hear you.
V square by R.
V squared by R. Yeah. So centripetal force is mv squared by R. Centripetal acceleration will be V squared by R. So V is, I think, as you enter here, you are going at a speed of 27 km per hour, which means if I convert this to meter per second, 27 into 10 power 3 divided by 3600. Okay, these two zeros and these two zeros will cancel, so there will be a 10. This and this, if I cancel by 9, I'll be getting 3 by
7.5. So
yeah, 7.5. All right, 7.5 meter per second into 10. So this will be 7.5 the whole square divided by radius is 80 meters. Okay, this you can leave it as such if you want, because you don't have to waste your time calculating this. So listen carefully. Tangential acceleration is along this tangent. So if it is increasing the speed, I would have shown like this. Since it is decreasing the speed, I have to show it in the opposite direction. So that means the tangential acceleration is this way because it is decreasing the speed. And then since it is centripetal acceleration is acting towards the center, so that means this is AC. So that means the net acceleration means you have to do vector addition. So that means this is your net acceleration, A net. Anybody not following? So you know AT, you know AC, you can calculate the A net acceleration. Let's read the question one more time. What is the magnitude and direction of the net acceleration? So that means you are supposed to tell me, calculate this one. So since it is 90-degree, right, I can directly use Pythagoras. So A net is equal to, of course, you can use A squared plus B squared plus 2AB cos theta, but cos 90 will become 0. So what is left is AT square plus AC square root. AT is this one, 0.5. AC is this one, 7.5. AT the whole square. This is AC and then there is a whole square. That's all. So similarly, I can calculate the alpha angle. So alpha theta. So the angle between the first vector and the resultant vector, I can take it as alpha. So you know that tan alpha is equal to opposite by adjacent. Opposite is this line. Anybody not following this? So opposite is this line. This line is same as this one. So which is going to be AC by, this is along this line is AT, adjacent. That's all. Do this math and you'll get the directional angle. Anybody not following this? After this, it's multiplication division. I'm not going to do it. Okay, so it's left to you. Concept wise, anything not clear? This why I said, sometimes in the theory, they don't tell you about this tangential acceleration, but they ask you in the problems. Any questions, any confusions? Anybody please ask. It's a slightly different problem.
Sir, can you show a solution?
What's that? You want the
No, sir.
solution?
Copy the steps. That's it.
Hmm?
I just wanted to copy the steps, sir. That's it.
Okay. Once you're done copying, let me know.
Yes, sir.
Okay. In your school tests, very often you can expect these kind of projectile motion problems. Okay, so be thorough with all the projectile motion problems. This is more like a proving problem, very easy, nothing very difficult here, even though it looks very complicated. Show that for a projectile, the angle between the velocity and the x-axis as a function of time is given by, so the velocity is u, this is theta, so ux is equal to u cos theta. So the angle between the velocity and the x-axis. So that means at every point, right? Listen carefully. At every point, the velocity direction keeps changing because it is tangential. So that means this is your velocity. So v, and then the angle keeps changing. So with respect to the x-axis, this angle keeps changing. For example, here it is theta is 0. Here it is 30 degree. Here it is 20 degrees. So it keeps on decreasing, and again it will start changing. So that means the angle here, so this is v, this is vx, this is vy, and this is the angle which I'm trying to find. So this angle with respect to time, it keeps changing. So that's why they put theta as a function of time. So in your mathematics, if you write f of x, what does that mean? So it's a function of x. So as x changes, this value will also change. Okay, so similarly, theta of t means it's a function of time t. So at different instance, the angle keeps changing. So tan theta, I get the clue that I have to find tan theta, because if I bring it on this side, I'll be getting tan theta. So the clue is tan theta is equal to opposite by adjacent. So that means opposite is vy, adjacent is vx. Vy is your final velocity in the y direction. Okay, final velocity is u, v is equal to u plus at. So initial velocity is u in the y direction. So uy plus at divided by vx is ux. Why? Because velocity does not change. So that means velocity remains the same. in the x direction. You don't remember that in x direction the velocity does not change, so it remains the same. So uy in the question they have written as voy. So voy stands for the initial velocity. The acceleration they have taken minus g, which because it is in the opposite downward direction. Vox is nothing but your initial velocity. That's all, which means you have proved what you are supposed to prove. So that means voy minus gt divided by vox. That's all. That's your tan theta, which means it's proved. Anybody not following? At every point the velocity keeps changing. Okay, if I exaggerate this, so only the starting point is difficult, so try to understand this. If I take a point over here, velocity direction is this way. If I take a point here, the velocity direction is this way. So at every point the angle keeps changing. If you take the highest point, the theta is 0. So velocity direction with respect to the x direction keeps changing. That's what you're supposed to find, which is using Vy by Vx. That's all. Any doubts? So take down this diagram properly. Okay, only then you will understand that velocity direction keeps changing because it is tangential. Okay. B shows that the projection angle theta naught for a projectile launched from the origin is given by. So now they are asking you to find the projection angle. Here it was the angle between velocity and the x-axis at every instant. Here they are asking you to the projection angle. So this theta. And they are talking in terms of h max. Hm is the maximum height. So it means this is your h max. H max, just now we use this formula u squared sine squared theta by 2g. Why? Because you know v squared is equal to u squared plus 2as. From this I told you it will come, because this will become 0. So u is uy is u sine theta. So u squared sine squared theta divided by g, 2g. That's why you will get the h max. But what am I supposed to find? So theta naught is a projection angle. So basically I'm supposed to find the theta. So basically from this I'm supposed to find the theta. So because it's given in terms of h max. But then they're given tan instead of sine, they're given tan. So I'm going to bring in the range formula. So range is equal to, why did I bring range? Because you see r is there. R is not radius, it's range. So you should not think r is radius, okay? Because we are talking projectile motion, which means you should know it as range. Because they are not explained what is what properly here. So range is equal to u squared sine 2 theta by g. So now I am getting the idea that sine 2 theta is having 2 sine theta cos theta. So if I divide this and this, sine theta will cancel. So one of the sine theta will cancel, one of the sine theta by cos theta will become tan theta, and then I'll be getting hm by r, and that's what I want. So I want to get hm by r. So that's a proof here. So it means simply divide this by this, equation 1 by equation 2. Or I'm going to simply directly do this here, okay, instead of writing too many steps. So u squared cancels, g cancels. You know that this is 2 times sine theta cos theta. So one of the sine theta cancels, This 2 will go over here. It will become 4. Sin theta by cos theta will become tan theta. So I'll be getting tan theta by 4 is equal to hm by r. So do the math. You have proved what you're supposed to prove. So tan theta is equal to 4 hm by r. So hence proved. That's all. Any questions, any doubts? If you know the formula, you're just directly substituting it. So the clue here is you should write the formula for hm, you should write the formula for r, and then you are dividing this by this. So sometimes, very often, if you don't know how to start from the LHS, you can start from the RHS, and that's what I did here. So you can start from the right hand side and then you get the clue and you can start doing it. Quickly copy this. Anybody still copying? Can I change the screen?
1 minute, sir.
Okay. Copy it. Was it Roshni? Are you still copying?
Finish, sir.
Finished? Okay. So that means I pretty much covered all the important problems in this page. Okay. This one, as I told you, it needs some vector basics. We'll come back to it later. 25 also we did. So this is also vector based. So let's try 21. 20 I already finished. Particle starts from the origin at time t is equal to 0 with the velocity of 10 j meter per second. So that means and moves in the xy plane. So initial velocity is given. So initial velocity is u is equal to 10 j meter per second at time t is equal to 0. Moves in the xy plane. So that means this is x, this is y, something like your 2-dimension with a constant acceleration. So acceleration is given as, since this is a vector, you can write this as a vector. A is also a vector. Meter per second square. At what time is the x coordinate of the particle 16 meter? So listen carefully. Let's say initially it is going at 10 j, something like this. But then the acceleration is both in x and y direction. So that means there is going to be some acceleration in some direction like this. So that means the final velocity is going to be, it's going to be moving both in x and y direction. Okay, very hard to imagine. Okay, because you may not have the basics for x1 ijk. But basically, I'm saying that there is some initial velocity and there is some acceleration, and they're asking you to find the at what time is the x coordinate of the particle 16 meters. So that means Sx is 16 meters. So that's the question. So basically, I'm supposed to find the displacement. So S is equal to ut plus half at square. So x, or I can do something like acceleration time. Okay, instead of doing it as x and y, can do it as a vector. I will show both the methods. Okay, both the methods will yield you the same result. So S vector is your displacement. So displacement has to be 16 meters in the x coordinate alone. So U is 10j into t plus half. Acceleration is 8I plus 2j t square. So I'm supposed to find the time. At what time? So that means t is what I'm supposed to find. So the displacement can be having something like this: Sx in the I vector direction, Sy in the j direction. Why? Because Sx is your displacement in the x direction. So that means you can multiply by I to make it as a vector. Sy is your displacement in the y direction. So if I multiply by j, it will become the y direction displacement. So if I add this and this, that is my total displacement. Anybody not following this? So I'm simply saying that this is your S, this is your Sx, this is your Sy. So if I simply write this, this diagram can be represented like this vector. So that means this I'm going to write it as 1 by 2 into 8 is 4I into t square plus 2 cancel. So t square will be there and then there is a t here. So 10j 10t plus t squared into j. See if this makes sense. I'm multiplying this and this. So 2 cancels. So t squared and then I have j here. So 10t plus t square. 10t plus t square into j. And then in the I direction, I have only 4i t square. But what did they say? This is in the x coordinate, they said it's 16 meters. So that means I can equate the I coordinates with this one and then j coordinates with this one. So that means, so listen carefully, this is 4t square should be equal to 16. So 4t squared, because this side is also I have I. So I goes away. So 16, 4t squared is equal to 16. So 4, so t is equal to plus or minus 2, so 2 seconds. So it means when time t is equal to 2 seconds, the displacement in the x direction would be 16 meters. Anybody not following anything? You see, it's the same formula, only thing I'm writing it in a vector form. Either you can write it as x, y, x, 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 y, 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 or vector. Vector means both x and y are included inside this. What is the speed of the particle at that time? So that means they're asking you to find the velocity when time t is equal to 2 seconds. So velocity is nothing but, you see, this is
I'm getting the distance as 40.
distance is 40. Where
Yes. This is equal to.
distance is already given here, 16 meters. So I substituted 16 meters here. So I'm equating the ice. Are you following what I'm saying? Whatever is the coefficient in front of I is 4t squared. So that is equated to 16. I didn't even worry about this one. I didn't ask you to find that. Do you agree? So,
Yes, sir.
or maybe did they ask you what is the y coordinate of the particle at that time? Oh, okay, you are right. So what is the y coordinate of the particle at that time? So that means they are asking you to find this coordinate. So time is t is equal to 2. So substitute it here and you will get the y coordinate. So this is 20. 2 squared is 4. So 24. That means Sy, the y direction is 24. Everyone getting that? Anybody not following? Any questions? We calculated the time t is equal to 2 seconds. So if I substitute here, I will be getting the y coordinate. So what is the speed of the particle at that time? So speed of the particle is again v is equal to u plus at. So v is equal to u plus at. But then I'm not doing x-axis or y-axis. I'm doing the vector. So that means I can write this as a vector. So, or else I would have written this x, 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 y, y, y. It's a vector. So v is equal to u is 10j plus acceleration is 8i plus 2j into t. T is 2 seconds. So that means I'll be getting 8i, so 16i. This is 4, 4 plus 10 will give me 14, 14j. So that will be my velocity. So what is the speed of the particle? So they asked you to find the speed. So can I leave it like this or should I do something else? What am I supposed to find here?
So find the magnitude, that is the modulus. That it is
Okay,
actually 30.
very good. So speed means you should find the magnitude. That means you should be careful with these words. When they say speed, they are asking to find the magnitude, which means it will be 16 squared plus 14 squared. So whatever you are getting there, 256 plus 196, whatever that is. Okay, so anybody not following? It's not very difficult, so it's very easy if you know the method. Okay. Okay, let's see. $22 is slightly confusing, but let's try that. I and j are unit vectors along x and y axis respectively. What is the magnitude and direction of the vectors I plus j and I minus j? So let's try to make some simple drawing here. So this is 1, this is 2, this is 3, this is 1, 2, 3. So I plus j means I plus j, so that means it's here. So magnitude and direction of the vector, so that means this is one vector. So this I'm going to call it as I plus j vector. 1i plus 1j. 1i minus j, so that means minus j means it will be going in the opposite direction, minus 1. So it means I can show it in a different color. So it's going to be like this. So this is going to be I minus j. What is the magnitude and direction of the vectors? So just by looking at the diagram, right, since this x and y are the same height, right, this will be, anybody, what will be the angle here?
45.
45. Yeah. So what happened to others? Everyone's sleeping. So whenever this is this height and this height, this x and y are same, right, it will be tan 45 because tan 45 is 1. Y by x will become 1, same. Similarly, this will also be 45 degree. Magnitude, anybody? Be 1 squared plus 1 squared. So that means the magnitude will be 1 squared plus 1 squared. Be root 2. So same thing over here, root 2. What are the components of a vector A is equal to 2i plus 3j along the directions of I plus j and I minus j? You may use graphical methods. So now they are bringing in another question here. So 2i plus 3j. So 2i is here, 3j is here. So that means somewhere here. 2i plus 3j. So the line will look something like this. 3 by 2, 1.5. So it will be looking something like this. So now they are asking you to find the components. What are the components of vector 2i plus 3j along the directions of this and this? So I have a vector this way. I want to find the component for this one and then this one, because this is, so usually we are used to calculate the components in the x and y direction. So now they're asking you to find the components along this direction and this direction. Okay, let me write it one more time. So if you have a vector like this, if you had some other line like this, so you are comfortable to calculate the components in x and y direction. So if I say what is your x direction, you can simply say u cos theta, u sin theta, something like that. But now to confuse you, what they have done is they are given a line like this. So they are asking to find the component along this line and along perpendicular to this line. Sometimes we will have this kind of situation, something like, inclined plane problems. When you have inclined plane problems, instead of taking this as x and y, we will take this as x and y. So in that kind of situations, we will have to calculate component here. Concept is still the same. This is theta means, if this is u means this will be u cos theta, this will be u sin theta. No difference in that. But when it is given in the vector form, how do I calculate it? That's the question. So whenever it is components, right, what comes to my mind is the dot product. So dot product says that a dot b is equal to ab cos theta. And what do you mean by that? If this is a vector and this is b vector, b cos theta will be falling on this. Okay. Let's say a vector is this long. B cos theta will be up to this length. So that means this will be b cos theta. So that means what are the components of a vector? So that means component of a vector means only this b cos theta in this direction. So that means b cos theta is what they're asking. Bit confusing, so take it down properly. Okay. So this I told you somewhere, I think I told you the meaning of geometrical meaning. Did I tell you the geometrical meaning of dot product? Yes, no? You folks know it or not? Okay, if you have the handbook, I'll show you where you can refer to it. So it's coming in the later chapters. So if you want to take a look at it, dot product, you can go to this page number 20 in your handbook. Okay. Some of you have not still collected the handbook. So if you want to collect it in my home, you can collect it. Okay. Because most of the time I'm not the center. So if you send me a message, I'll send you, where you can collect it. Okay, coming back to this, look at this. This is A vector, this is B vector, this is your theta. So if I want the projection, suppose if I put a light over here, the shadow will be falling only in this region, and that is what is your B cos theta. So A dot B is nothing but AB cos theta. So B cos theta is nothing but your projection of B on A. Anybody not following? Any difficulty? I'm sure it's slightly confusing. So let me say that one more time. So listen carefully. So this is A vector and this is B vector. And if you put a light lamp over here, right? So the lamp is cast some shadow here. So that means this is your B cos theta. This is your A vector. So it means the dot product is nothing but A dot B is equal to A B cos theta. B cos theta is nothing but projection of B on A. So you see projection of B on A. Okay. You can say it the other way also, projection of A on B, because if I write A cos theta, projection of A on B, you will get the same answer. So that means if I want to find this component along this vector, I can simply say I want to find projection of B on A. So A will come on this side. So that means B cos theta is nothing but your component. So take it down properly. Component of B in the direction of A. In the direction of A. Or if this is confusing, another way of saying this is projection of B on A. Projection of B on A. So both are same. So what I'm trying to say here is they're asking you to find I plus j is here and 2i plus 3j is here. So that means I'm supposed to find the component here. So that means A dot B is 2i plus 3j is one thing and I plus j is another thing. It means if I want to find the dot product, I have to do it like this. And then the A vector. A vector is nothing but Pythagoras theorem, 2 square plus 3 square. That is what I'm supposed to find here. Dot product is multiply the i's together, multiply the j's together. So 2 into 1 is 2, 3 into 1 is 3. So that means it will be 2 plus 3, 5. So this will be 4 plus 9, 13. So root of 13. That means it will be 5 by root 13. I'm sure some of you are slightly confused. Anybody like that? Any step which you are not following? Dot product means you have to multiply this with this. Then you have to multiply this with this. And then the A magnitude means square root of 2 squared plus 3 squared. 4 plus 9, I'm getting 13. 2 into 1 is 2, 3 into 1 is 3. So 2 plus 3 is 5. And that is what is your projection of B on A, or the component. Actually, I think I made a mistake here. So this is B, right? I'm taking this as B. So I think I made a mistake. So this is your B vector. This is your A vector. That means I made a mistake here. A dot B, no issues. This B vector is this one. So take it down properly. This is B vector and this is your A vector. But then here I made a mistake. This is A magnitude means this magnitude. So it means it's root 2. That means it will be 5 by root 2. Similarly, they asked you to find the components in this direction. So do it yourself because you know the direction I minus j. So instead of I plus j, you have to do the same thing. Only thing I will be getting I minus j here. So I will be getting 2 minus 3. So 2 minus 3 divided by root 2. So minus 1 by root 2. That I will leave it to you. Okay, so do along this direction I minus j. Okay, so if you are not following this problem, don't worry about it. The theory is coming in the later chapter. In the 6th chapter, we'll study more about this in the 6th chapter. For now, you can go back and study this theory in the handbook, page number 20. Okay. Okay, so it's already time. So I'm going to stop here. So your homework is to complete as many problems as possible. I think I have covered more than 10 for at least 10 problems. I think I covered. So 1 or 2 problems which are difficult here, I will do it in the next class and then we are done. So next class, we will have one more class for this numerical and then you will have the test. So today is 26, 28, we will have the numerical, one more numerical class. And then 30th, you will have the test. Okay. So Friday, you will have the test. So get started, start studying. And this is also just like the previous chapter, you will have more of numerical questions because not much of a theory questions in this. Of course, you will get the projectile motion derivation, circular motion derivation, all those things.